Hello Earth, welcome to episode 23 of season 4 of Making Cell, a series of videos where I record myself designing and implementing a programming environment called Cell. So if you're just tuning in for the first time, I recommend you go check out the official page of the project at github.com/autocodenl/cell. The link is in the description. So the last session was a very good one. Things are running again, and I'm ready to understand the other sequences that are successful. We basically, I would say optimize. Well, yeah, we did optimize in the sense of not making it do any unnecessary work. So I guess it's optimization. I also had a bit earlier today really good ideas. Well, ideas that seem really good to me concerning types and yeah, like the ideas are just taking further shape. I would say almost like I wouldn't say full circle, but that's almost the feeling, really. So if you have time and are interested, you can see them here at the top of the development notes. The entry for today, January 7, are there, and yeah, you might find them interesting. And anyway, so now we are going to take the test. We're just going to separate these other tests here, because yesterday we did this one, 10 plus 1. And here what we were doing is updating the value, right? No, we're updating the sequence. Yeah, I think that's a good one. Let's separate them here. Yeah. So we can do something like this. So we do this. Uh-oh. Yes, I always do the same silly things. Noise. And now, what was the tag for the other one? Of course not. Yeah, it's okay. I don't have any tags here, and it's fine. It's more than fine. So I'm just gonna take all the pretty logs that I left. So we can look at again what's going on. Yeah, honestly, I don't need this one here. zero space response. It goes all the way to 17. These are the recursive calls that don't do anything. It says respond call, right? And the ones that say data space. En resaca. Yeah. Yeah, so I have this one. So yeah, the recursive calls finish, tuk tuk, nothing happens. 16. We put the whole thing on the dialog. Actually, sorry, where's the put call here? I'm not seeing the put calls. Yeah, I was missing that, of course. Yeah, I was missing this one. Quite a crucial one. Yeah. Okay. Where are you putting the dialog? This is already a new one. That was perfect. So you start with the 8th put here. What was the list of puts from yesterday? I forgot. Yeah, the 8th one is for the dialog. Brilliant. So here we start with the respond. Yeah. Okay, so this is the read, and then we go again here. I don't understand this thing. Where's response dialog? Omitted. It should just be omitted. That's just wrong. Yeah, that should be the correct one. Yeah, that's more like it. By the way, this should not well, yeah, it should break something. And also it should be, sorry, where's this omitted coming from? From the tested, right? Yeah, I like the squares more. Only one? Good. All right. Valvular transistor. All right. It's crazy. Looking at the data always helps, especially when I'm copying and pasting stuff like this. Okay, now it's really working. I'm encouraged by the speed. And now okay, now we go to put number 9. Where are you? Yes. I'm missing the put. Sorry. Yes, this is the one. Because this is a dialog that is properly set. And then look at that beauty. Oh, I didn't notice you also have the milliseconds here. I can see how long it took. Pretty cool. When this is useful, it's gonna be so useful. Yes. Okay. So 10, 10, 10. So we just go from the top. So we need to respond again to this one. Because the change is in the definition, not at the message. So this is just fine. So no put. You're looking at this one. And here we have a reference, right? It's a reference to the call. So it doesn't change. And when we go back here, this is very interesting. So only when you hit the add, you know, yeah, because in one you're checking, I like this, I really like this. Back to understanding, so respond. It's, now that the first sequence is very clear, starting how the update happens. When the update happens, we take it from the top. The first two call prefixes work with the existing definition. One is the native call. It works well, hasn't changed, so we leave it. The second is the reference. It hasn't changed, and we leave it. When we hit the third call prefix, then we realize that the definition has changed and we update it. Brilliant. Then we go to the top. Sorry. Bam, 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 bam. Okay, let me just change the song. Yeah. So where were we? Yeah, sorry, I just got lost for a second. Yes, we're looking at these beautiful logs. So here we just update the sequence and then we start from the top, right? Yes. And we say this should be 12 because +1 is now +2. So we update that. This one should not be updated. And then we hit the call one again. Yeah, now we check int. Sorry. Okay, now realize something that is a bit silly. When you change the thing, when you re-enter, you're also rechecking it. It's a bit inefficient. It's only for the first one. Yeah, let's just write it down. A bit of inefficiency. The first call prefix is changed. When we re-enter, we check it again. But to not do this would require us to pass a flag saying the first one and I just changed. Don't like that at all. Coma y mi sal. Alright, so no. So we go in again here. Okay, that makes sense. I get lost immediately in these things. I want to blame myself instead of my logs because it's easier. Yeah, it's the same. So you update it. Boom, 12. Okay, native didn't change. Move on. This is the same. When does this get updated? Here. Here. So we start at 17, right? No, 16, right? So 16 is a knob on the first call prefix, 17 is a knob on the second call prefix, 18 triggers the change on the definition. Then 19 updates the value of the first step of the sequence, which is the whole first call prefix. Then 20 is a re-enter there, nothing happens. 21 is for the reference that is unchanged, no put. And then 22, we're finally hitting this one, and we're going to update the value, and that's it. That is it. And then we go to the top again, so it would be 23 and 24 reference, 25th the definition, which is finally fine. And then there's nothing to do. And then the plus is the same. Yes. And there's nothing else to do, right? Yeah. Look at how 18 responds here. And the dialog, perfect. It's perfect. Okay, it's really good. 18 was this one, right? Yeah. And we updated the definition. Yeah, beautiful. Okay, I get it. This makes sense. Okay, which one is the next one? It's a nested one. Let me improve the logs a little bit. We don't need this, or do we? No, I think we're fine. No, that's a bad move. Yeah, much better. So we put this. We start responding this one. We get a definition. So we're getting nested plus 110. Yeah. We found the thing here there. And now, yeah, just get the definition, which is, well, not the definition, we're putting the arguments. I wonder if it makes sense to put the argument on the first step. It doesn't matter because we re-enter. There might be things to read. No, it's fine. I like it like this, separate. I think. No, technically, yeah, we could do that. So we put the arguments as part of the first responded path. We re-enter again. And then we put the first step of the sequence. I think we do. Oh, here I need to rename these variables because I have it current value, new value, a previous step. Current expansion. Here's should. Actually, in this case, it makes sense to leave it as previous. It's what it was before. But then in the other one, I say current value, new value. No, I'm gonna change it. I'm doing this slow on purpose. Well, maybe not. All right. Please check the diff of cell.js and give me md and see that for the changes, all the changes in the code were properly reflected in the annotated source code. That seems to work. Still working. Nice. So why did I just, maybe I'm more tired than I think. I just forgot a bit what I was doing. I know I was looking at this stuff. Yeah, I was thinking about putting the whole thing in there, like the message and the new expansion, but I decided against that. And then yeah, I was just doing a diff. Yeah, no, it's fine. Oh, it's taking its time. Nice, we got it. Yep, that's a good catch. Okay, let's recheck. So we're good. Let's see if I can stop getting new windows. Respond. Re-enter with the definition. We update the first step. Yeah, we definitely need to test the case where you change the size of the sequence. I was just thinking how to do that. It's okay, I'll do it a bit later. I'm thinking of masking if the new definition has 7 and the existing has more than 7, already wipe 8 and 9. I almost need mute. I am needing a mute put or mute wipe that doesn't re-enter, that doesn't trigger some response. It's very funny to see it. It's the exact same thing I encountered with Gatob front-end library. Yeah. Okay, all this slowness is I'm developing intuition with this. So we go again here. We put the definition, right? No, where am I? No, we put the definition in 3 already. And then we go again to the top. We have a reference. We put the reference. We go to the top again. There's a native call now there. It's a new call prefix. We put the results. This is quite nice. What was DS? Data space, of course. So how one, 2, 3 call prefixes only. No, 4. Same as before. Same as before. What am I testing? This is the same. I know it's a nested one, of course. It's the same thing. It will be the same thing. Right? Yeah, it's just nested. It's the same thing. Yeah, the 7th put. Where's the 7th put? It's the one that puts a result on the actual definition. You can see the recursive calls here responding. That's it. Yeah, it's the same thing. Slow. You should watch this at 4x at least. Alright, but this is good. Now what? We have a message that is a hash. Yeah, honestly, I'm not interested in looking at that with... Okay, let's just do it. Alright. I get it. What am I doing? Ah, that's... See how it removed the dash? Right. Yeah, putting the message, then putting the thing. You could almost look at the puts, really. the path and the puts. Put it there. And then we resolve the message here. Butane. Then we go from the top. Nothing to do. Here, definitely something to do, right? Yeah. Actually, no. No, this is the actual call, right? Left bar 1. Yeah, it's a call. No, nothing to do. This respond call is really not working for me. It's like I'm like skipping it. I'm lost again. Right here we just get the finisher and there's nothing else to do. Why am I... I'm setting the value, of course. Go from the top. Nothing else to do until we set def. Perfect. The recursive calls on the put. Perfect. Very simple. Yep. Looks good. So what is going on here if I do this? Yeah, let's just do it here. So we start here. It's a set call. Where's this N1 coming from? What do I want to do here? What if I do this? This is just a call. No, it's just a value. Not much else, yeah. Yeah, I don't get the point of the test. Yeah, sure, it would be good to show what we're passing here for not passing a list. But right now, honestly, I want to deal with this. This is the moment to deal with fizzbuzz. So we put the whole thing. We respond with the 4. Or we put the N4, which is perfect. It's third time. Yeah, there's nothing else to do. That's the definition. All right, now for the good stuff. Yes, it was pretty fast. Let's just make it that. CR is more than, I don't know, 30. Okay, we start at 4. You're responding on on this one. Ah, look at that. The definition goes first. Sure. And now we're setting. This is perfect. We're putting the message. Now we should be putting the is a no because it's at the top. 5 is perfect. Here we're expecting this to, sorry. Yes, here we put the stuff. So this is re-entry. 5 is the re-entry. 6 is putting the, what is this? Okay, this is correct. Yeah, maybe the put is triggering itself circularly. Yeah, actually, that would make perfect sense. But at some point it should be convergent, right? So again, fizzbuzz, nothing. Now for the good stuff. Why does it do this? Ah, because it's a native call. I'm not implementing put, right? That's the problem. Yeah. So should I make it mute, this put? Yeah, no, it shouldn't be mute. It should do a put and return true. No, wait, because I need the value. I'm in a bit of a pickle here. Oh, I can just make it return true from the outermost. Message context path. Not bad. And then it should not be false. It should be no such native call. When you put here, it's never gonna be false. Yeah. It's a bit tough, but I mean, I was dreading, well, not dreading it, but thinking about this for a while, and now I think we pretty much understand why it happened. I cannot complain really. This is good. So in the native response, I can just do new value and just be done. Because if it's an error, it's like it's the end of the road. What I want to mark is the fact that it's a put. Yep. This is finish. No. I'm a bit lost. Put fizzbuzz. Updated. Dialog, okay. Then we put the other one. Good. Set the message. Set the first step. Make the call. Oh, again, fizzbuzz. Okay, now for the good stuff. Why doesn't it do anything here? Yeah, this is correct. It did put the output there. Let's look at it. Yes, it's there. I need to implement push. How was I expecting for this to work? Look at this put. So we'll always keep on putting. Only a sort of idempotent put. Yeah. So there should be no diff in this case. So let's just write this down because I will forget perhaps. Attacking fizzbuzz. Native should not return false but rather an error if you send something to it that is not there. Well, I'm not sure if that's, well, shouldn't it default to instead? Yes, it should change. We need to change it tomorrow. Okay. Native needs to call put, annotate that native returns true in the case of a put, because things want to stop the outer recursive call to proceed with stuff. Native doesn't have push, but the cycle happens because put keeps on calling itself. Put needs to return a zero diff if it doesn't change any paths. We need a mute put. Then call it mute. If returns a zero diff, proceed. Otherwise, return true to stop the outer. But no, in the case where there's a change, I don't want the inner put to be mute. I want it to be mute only conditionally. Only if it doesn't change anything. But in that case, silly, just make put not call. So respond. If there's no diff, what is there to update? Okay. So always make the put a native return true when it calls, no, not treats the call to native put as a stopper for the outer respond. Yeah. In the case of a no, not either. When the diff is 0, don't return false. Just keep on going. But wait, this is impossible. In that case, we'd be overwriting the diff from the previous result. this is highly inconvenient. We need to monkey patch it. Okay, now today I'm really ready to be done. I want it to work. I cannot say I'm having fun right now. It's a bit too hard to be fun. But if we do all of this, let's just think a little bit more, just a little bit more. Can I say I'm making a put? Oh, this could be a complete showstopper. I made a put. I want to put output to an empty text. If there's a diff, great, we have a diff. The second time around, I want to put it, there's no diff. Then some response should be smart enough not to override it. The question is, how do I know if that's the correct approach always? Is it always correct to not put a diff? To not override a diff with nothing? I think so. We are treating put almost like a got of change event. All right. If we solve all of this and we add the push, we'll be good. No diff on same paths. No. So respond if zero diff. Native is part of the language, you're right? Definitely. I need push and then we're good. All right, I'm gonna stop here. Thank you for watching.